Hello everyone, this is Bradley. Today this is to replicate a kind of Houdini growth effect in Blender using animation nodes. There are different variations of that effect, and in Blender each variations will need a little different approach. Today I'm going to talk about a variation which I think is the most intimate. I'm also going to use the preset library which you can download for free from the link in the description. Also, there is a server created focusing on discussing animation nodes and geometry nodes. Feel free to join and describe your thoughts if you want. So let's start. So here we're in Blender and there is a routine setup for these decomposed text nodes. I've made a tutorial talking about this decomposed text node and with this routine setup. If you aren't sure, you can just replicate what we have done here. I think it's kind of very easy to understand, or you can follow, you can check that tutorials later. The link is provided on the right upper corner. There's an eye icon. But either way, we're not going to use the setup right now at this moment, because it's always suggested you start with a kind of very simple example, like a single component, and then extend it to a more complicate multiple examples with multiple text object kind of stuff. So let's firstly disregard this part of the node tree. Let's start with a simple object. I think I'm going to start with Suzanne Monkey because it's very representative for Blender user. And the Suzanne Monkey mesh has kind of issues, because if you hit L, you are able to isolate the eyeballs. The issue is that the eyeball is not really connected to other part of the mesh. Will cause some issues when we are working with that. For convenience, I'm just going to delete all these kind of eyeballs and fill these holes. I don't think it's a very hard requirement for you to have a closed mesh, because normally you don't really model with opening mesh. So I think this is, yeah. Next step is I'm going to use a distributed matrices to distribute the volume within the space. So let's take a 4.4, and I'm going to enable this so everything has been offset. This is a low resolution grid, so you can increase the resolution if you want. I'm just going to keep that low at this moment. Another thing I want you to actually realize is that the size of this entire grid 3D space is not compatible with our Suzanne. A very easy way to actually deal with this is I'm going to take the object attribute inputs. I've explained this node in a separate tutorial as well, that this attribute is not anything related to geometry nodes. Please be aware of that. Here we are going to know the dimension of these Suzanne monkeys. Usually to use this node, we are going to, for example, goes to transform, and we're going to copy data path and place these informations. But the only place that I can see the dimension is here, and you right click, you did not see anything. I don't know why, but anyway. In this case, actually, you just type dimensions and select our Suzannes. It will work. Just to make sure there's no typo. Yes. So you get a dimensions, and you can confirm that 2.7, 1.7, 1.9, which is exactly the same as what we can see in the viewport, which is nice. So in this case, we can put these values, object width and the length and the height. Actually, it says convert. Okay, so we need to separate vector, and it will convert to vector. Okay, this is nice. And we put the x, y, z's. So now we have a grid which is really filling the basically the bounding box of this Suzanne. So now we can increase the resolution, which basically makes things a little bit nice. I think the X and Z is something I really want, or you can increase the Y as well. So you can also decrease the scale of the matrices so that you can see how this point is being distributed in this bounding box. So here I'm going to mask out some points which are not inside the Suzanne mesh. I'm going to use an evaluation which is called is inside the volume. And there is a dark green socket which you don't really commonly see in animation nodes. It's a very barely used socket. And sometimes if you see there is a color of a socket or a socket that you do not really recognize, easiest method I think is select the node, hit W, and it goes to left, and then you are able to get a kind of inputs to know the object, the socket type, which is called a BVH tree. The BVH tree basically to evaluate the surface of this object mesh. But in this case, I think you can directly select these objects. If we are working with text, we are going to do a little bit of modification, but so far this is not really a problem. And then you need to input the vectors to the place for your evaluation. So it outputs a boolean. So is that inside the volume? Yes, no. So based on these yes, no questions, we're going to put the vectors and mask that. You can also put the matrices, but I'm going to tell you why that we need the vectors. So now let's view our vectors that are being generated. So increase the scales, you can increase the resolutions so that you see a lot of white points being distributed within our Susan head. There's definitely some issue, like you have the only few minor points at ear, simply because our Susan mesh is just so tiny. You can also, I don't know, yeah, I cannot come up with anything other than just increase the resolution. There's also some method that you can potentially like make a solidify modifier so that it increase whatever stuff, but I don't think it's something that I recommend you to do at this moment. At least, yeah, probably no. Earlier I mentioned that we need a vector because we are going to use a node for which is called a tree form vectors. So this node is basically trying to connect all these kind of points based on the distance. So now actually let's output a mesh. So here let's turn off this Susan head for this moment, and we do not see anything with this target because it's just a lines. So if you hit tab and it goes to edit mode, you can find all this kind of point being actually connected. This is a little bit different from what I want. Is like the vertical space is being separated too much, so they're not really connecting to each other. Sometimes you really would like to actually fix this kind of issue to more get a kind of even spacing, so that you do have connection at least at some point. So trying to balance these issues. Probably you would like to generate a 100% identical grid. I'm not sure. Probably does not really work. So you can tweak these values in your free times, but I'm not going to continue on this. Okay, I'm going to mask some points. So previously we're using all this kind of mask list inside of volume. Here I'm just going to randomly delete some points. So let's take the mask vectors and take that into. So we need to solve to actually define which point being generated and which point does not. So you can either use noise solve, but if you're using noise solve, always try to remember to remap solve or remap for noise, because the noise solve is generated from 0, 1 to 1. We need to remap that to 0 to 1. Here we do not see anything, which makes our workflow a little bit awkward. So the best method is just to use the find shortest path. Then once we have that, we still do not see anything. Let's change the type into the path. Actually, change the type into the spline. And let's use the curve object output. And then increase that. So by change this source, we're change the origin of our spline start. So it does not really look like something interesting. It's just kind of a formal grid. Just to be aware that you don't necessarily to use this distributed matrices grid. You can use anything, including the random transform. Including the random transform node that this kind of preset that I made in the past. Here, what we can do is that we can put a matrices list into the place, and Actually, I'm not going to use this one. Let's just add a vector wiggle and create a list offset vector. Put our vectors into the counts and the vector into the offset, just to be aware the amounts that you generate. So let's take a vector from value 0.1. So now we have kind of wiggling or this kind of spline. This still not looks very interesting. We need to deal with these, like decrease the size, increase the frequencies. I don't know. You have to decide by yourself how things has been manipulated, all these kind of parametric things. It's very hard to actually get a formal values to all this kind of stuff. And finally, start with a source which is internal. Another thing, actually, I forgot to mention is that to increase the amount, so that the more looks kind of tree expansion, as you can see. And then let's try to hit that to 0. So you can see a tree has been expanded in Suzanne head. It looks kind of interesting already. The only issue is that I don't have enough the points to actually distribute. So you have to be a little bit careful, because now the moment we're already hitting the execution, which is 33 milliseconds, it's not very much. This is completely acceptable, but just be aware that if you're increasing the points more and more evaluation, it takes more and more energy of your stuff. Actually, now this looks interesting. So be careful with the values. Do not really try to push that too hard immediately. Like, oh, I would like to have more resolution, so like let's type 100 and your computer will freeze, crash, whatever, blue screen, black screen, dead. So this is kind of idea, and just a try, and it's kind of very interesting. I like it actually. And what we want, however, is I want to randomly change all the kind of source. Also, you can have multiple source. So here are several things that we can do. Let's take a random number. So this is the way that you generate a random number, but I need many points. So let's take that to maximum. So let's get a list length, so that we know the maximum amount of points we have. So let's take a maximum. So take that to maximum, so that we are always generating a single random number. You can directly plug that to source, I think. Yes, there's no issue being created. And you can change the seed, so it change the whatever. Another thing is that you can potentially increase this list and then put that to number. So you can have 5 counts. Let's take that to 2. It's not very easy to actually see what's going on, but you can see actually this tree started from 2 origin, like these 1 points, and there is another point. I'm not sure where does it come from. Oh, like so these points and these points, I think. Yeah. Anyway, so this is just a rough estimation. So you can play around with this setup and increase the kind of thin lines, add a material to that kind of stuff. So now we get roughly the result, but it does not look anywhere interesting or anywhere beautiful. There is one step that can immediately improve that better, which is called reset spline radius. If your preset library contains this re-evaluation and it's checked, please turn that off. Otherwise, you will see some problems. So now the execution time is 64 milliseconds. If let's plug that in, immediately it becomes 250. I'm running a very poor laptop, like 2.6 GHz and 4 cores. So it's a very poor laptop. If you're using desktop with better like 8-core CPU and higher speeds, then this number might be lower, much lower. But I still always be cautious with all this kind of stuff while you're working with stuff. Otherwise, if you blindly turn on this re-evaluation, it might just freeze, lagging. I don't know what will happen. And immediately we get our results, very beautiful. And you can increase the start or count radius, but anyway, let's increase a little bit thickness so we can see it better. Okay, it looks nice. Just to know that you can also reverse this, like the start is 0, stop is 1, so that everything goes reversed. Thick at the terminal and thin at the start. You can also change the gradients. So if you hit use, goes to socket settings, there are hidden settings. That's basically, yes. You can try to change the interpolation. It just goes kind of weird. I don't know what does it look like. But I usually just keep that exponent so that it keeps being thick for longer times than expected. Otherwise, if you turn that off, it looks like a much thinner. But it's kind of linear interpolation, so yeah, whatever. So talking about animations, I think this is trim spline. You just trim. So now we have nothing, and then we have everything. This is really just nice. I think this is kind of very, very nice. There's also a node which is called trim spline unit normalized, but I don't really would like to discuss this at this moment, so probably pick another time. I think that this time with this trim spline is already satisfied. It already satisfying. Just to wrap up what we have done, basically there's lots of random seed that you can actually control. Everything is just a procedural. That you can also change the amounts, like you can decrease the amounts, which may not really look kind of good results, but maybe that's what you want. You can also increase the amount. I usually recommend 7. I think it's 6, 7, 8 is already a good number. What if you turn that very high to 14? It just looks like more points. Still looks nice. I don't know. Change the seed. Looks interesting. Whatever. So many possibilities. I'm not going to. Another is the threshold. You can increase the threshold to the right side so that more points be included. If your computer gets stressful, you can decrease the amount of points so that, but you also delete the kind of resolution. So 6.06.5. You can also increase the frequency, change the seeds. So there is change which minorly affects your results. Other changes might largely change your results. And last thing is resolution. Just always be careful with your execution time. Save your progress while you're working, which is very important. So now we finish a single thread. Pretend we have the text. So actually let's make a text object. Text object will contain billions of problems, including, so now if we select this text object, try to use this selection, and you find it's not working, it's not being updated. The reason, this is a Blender limitation, that text object is not working the same as the mesh object. For example, if I have a mesh, if I have a cube, and for example, if I take a boolean, and I cannot really select this text object, it just does not work. And the same principle has been applied to here. Basically, it's kind of unfortunate, you just have to get text data. So let's select this node, goes to data inputs, eevee tree, and we can select this. Can we actually select this object? Yeah, now we can select the object. So you have to read its mesh data. In this case, I'm just going to keep that mesh, and I will tell you why. So let's move on to the text. I'm not going to spend too much time on a single text because it does have issue. The text is generated on XY plane, which causes lots of actually the issue, because if you're talking about dimensions, it generates its Y longer than the Z. Actually the Z is 0, while it's not a stand up front. You can definitely rotate that, but it will not update to Z. Just to know this kind of difference, and I will show you how it actually causes a problem later. So finally it goes to our most beginning, in which I showed you this routine setup If you are unsure, just copy this setup, and we are going to use that. So the good part of this stuff is that we are automatically generating all this kind of text, okay, which is kind of very nice, and it's completely procedural. More importantly, we actually know the location for each object, because you can see its center, its origin center is at the center of each text object. Previously, we are working with a single unit, and each unit is generated at world origin. In this case, we have to transform our units according to the where this new text object being located. I will show you what actually does it means. So first, let's extrude that. So 0.2, 0.15. Yeah, I think this is nice. And then let's start to rotate our matrix, because I really would like just to see that front. We can also change the alignment to center. Just to know that if we change the alignment to center, sometimes it looks kind of a little bit bizarre. There's not really a way that I can fix that. You can change that to left, but I don't want to have these origins standing to left. So there will be some little bit issues if you're looking at the cameras, because it's obviously left shifted. But I think you can manually offset with this offset matrix. I'm not going to cover that in this case. We're going to evaluate each object differently. So let's take the loop through object. So now we have a loop. We have the previous setup, and I don't want to waste them. So let's just take these objects. Next thing, I think let's just firstly work with this object. We need a mesh data. So object mesh data. While you're working with multiple text, multiple setup, try to change that to low value first, in case it crash your computer by any means. So let's see what we actually get. Does not really work. Not the same result as we see earlier. But if you increase, it still does not really work. Something must be wrong. Okay. This is one moment that we need to actually look at what's actually being the issue. And if you look at the issue, as you see, although we rotate that with object matrix, but we are not changing how the mesh is really being generated. So to Blender, it's still, so even if you rotate and not rotate that, the dimension is not changed. So dimension does not change based on the rotation. So it's still lying down in Blender's opinion. In this case, in short, the Y is actually Z, the Z becomes Y. So now we actually stands up. So now let's look at what we actually created. So now we still get kind of upright result, but it still looks kind of ugly. We don't know why. Before you increase the resolution, there is actually a reason that why it happens like this. The reason is basically there are multiple reasons why it looks so ugly at this moment. One reason is that we are generating multiple spines within the same loop, but we are writing to the same object, so it's keep overwriting the data. So what we do is not to generate this curve object inside loop. You can, but you need to use a little bit different methods later. So just to keep things simple, I'm going to take the, let's go to outputs, hit this plus icon, take the spline list. Finally, we're going to output this spline list. So now we have something. It still looks kind of weird. The second reason that why it looks kind of very ugly is that our distributed matrices is always generated at world origin. So all this kind of grid looks like the same in that case. In this case, what will actually happen is that we need a vector list. So take decompose matrix. And we need a vector list output, vector list input. So in this iterator, let's take a vector list. Translation into vectors. And last step is we need to change all this kind of evaluation. Put the vector into locations. So we offset everything, immediately should give the results, in which we have HER. And the execution time is 1/1000, which means 1 second. A little bit too much to me, so I will just keep that simple, like HE. So now this is still acceptable. If it looks kind of too thick or other things, you just change all this kind of parameter. Then it will fix these things. Next thing I would like to do is that I found out that actually, so previously we switched the Y and Z, but actually if you read the Z data, it's a 0, so it does not actually read the dimension of these objects. For some reason, it does not really read very well. I think it's still the issue of the text difference between text object and original object, I think. So this case, to solve that, just manually, let's take a 0.3. It's kind of solved better. So Y 0.3, it's basically 2 times with the extrude you have. So you can plug the extrude and plug that to the loop as well. So using the parameter. So let's use parameter float. Float math. And use that to insert the Z from the dimensions. Or you can just directly use the float without times 2. I don't know what it actually look like, but anyway. So 0. Ow! This is too much. Yeah, I think this looks nice. It looks kind of a normal character. And there's lots of things you can change. Talking about the random seed, there is the index seed preset. I think I'm going to make a tutorial separately talking about this. But currently you just put the index to the place and put the seed to whatever place that it needs a seed. For example, the random vector, noise wolf. It's possible that you use the same seeds or use different seed. It does not really matter. The seed is there. Whoever one you use, or whichever one you use, does not really matter. There are also many parameters that you can take finally at the start of the loop. Technically speaking, you can make these into presets, but I don't think there is a general use of these whole things. So you can change the seed that changes everything. There are so many parameter stuff that you need to deal with that I'm not going to too much detail. For example, let's take the 14 and take the count to lower. Okay, last thing, talk about the animations. If I would like to trim different objects differently, I'm just going to keep this trim splice inside. Just to always know, because while we are running the loop, each of object, text object, is being treated differently. Which also means if you would like to have different color, different radius, different trim process, you always work inside the loop. So which means if you would like to have different color for different splines, you need to put this curve object inside the loop with another special method. to prevent overwriting the same data, which is called target 001. But I'm not going to such details. I'll just left you to consider how to do this. I'm just going to talk about the trim splice. It's pretty simple. It's just an evaluate for, and I'm going to take the strength into the end and change the type into location. So what's the location of all these kind of text objects that we created? It's the location that we previously get from that from the iterator. So you can just take a reroute, plug that place. So in this, at this moment, it does not really change anything. But as soon as if you take a object controller for, plug that into place, it starts to affect our object. As you can see how the animation has been gone. The spherical valve does not really look very nice. Usually just use directional valve and change the type to Z. So now this really looks good. So originally nothing. Later everything starts to grow. This is kind of idea. So you can change whatever you want. It's basically procedural, and change the resolution. There's so many things you can change. I probably would just stop here and left the rest of the things for you to consider. So I think this is it. I hope you enjoy this tutorial, and I'll probably see you next time. Bye bye.